Flying is great, but easing hundreds of tons of aircraft onto a runway safely requires some pretty sophisticated landing gear. Let's see how it's made. This heavy piece of steel is the undercarriage of a KC-135R airplane. A landing gear comprises a central shaft to which an axle and wheels are attached. They begin machining the shaft. This digital lathe machines the exterior surface of the part. Sprays of water and oil cool the part, which heats up due to friction. They're now going to pierce the shaft. This drill head will remount the inside of the shaft. Alignment of the head must be perfect, so they're cautious with their work. The perforating gets underway. Turnings from the cutting are saved, and these will be sold to foundries where they'll be recycled. We see here the cutting tool used to pierce the holes in the landing gear. To perforate the part, very sharp cutting tools are used. Here, they complete an attachment hole. The hole is enlarged on its sides as required by this machine tool. The part is cooled with a mix of water and oil. Cutting is completed and the hole is now cleaned out with compressed air so that they can proceed with a visual inspection. Here, 3 pieces are rough cut at the same time by this machine. Because they'll be used in aviation, these pieces have to be machined to perfection. The machining of the shaft is now almost completed. This deburring unit polishes the machined surfaces with a compressed air tool and sandpaper discs. And now they have to verify the dimensions of the parts. This digitally controlled machine has 3 axes and does the verification with extreme precision. Here, another unit allows for the machining of parts with greater dimensions. This facility also reconditions used landing gear such as this one from a Boeing 707. They strip off the paint with a sandblaster to verify the condition of the parts with great precision. And here are those parts stripped clean. But a visual inspection is not enough. They can detect cracks by magnetic particle concentration. They magnetize the part and any cracks will become visible under ultraviolet light. Now it's time for the shot metal procedure, where they spray steel balls onto the metal surface to increase its resistance to fatigue. Before repainting the part, they first plate it. The part is immersed for 10 minutes in cadmium, which forms a protective coating on it that will resist corrosion. Then the part is quickly soaked in a weak concentration of chromic acid. Water, agitated by air jets, cleans away the chromic acid, and the part is rinsed with water another time. The part is now baked at 190 degrees over 23 hours to remove hydrogen induced during the plating process. Then the part is immersed in liquid nitrogen at -129 degrees centigrade before it's inserted in order to reduce its size. This collar is easily pushed on with a hydraulic jack. Reheating the collar makes it return to its normal size. Now the different components and the leak-proof joints are inserted into the piston. The shock absorber tube goes into the piston. This part absorbs the shock stresses when an aircraft lands. The piston is now slid into the cylinder, and they verify that the shock absorber is leak-proof. Fabrication finishes with paint baked in an oven. Some 6 to 8 months are required to make a new landing gear, and between 6 to 8 weeks to recondition a used one.